In today's video, we are going to be talking about combination circuits. After watching this video, you should be able to identify the parts of a circuit that are in series and the parts that are in parallel. And then beyond doing that, you should be able to break the circuit down to determine the resistance, current, and voltage at various points in the circuit. Okay, so it's basically a combination of the last couple lessons all put together, so it should be a pretty good time. Let's get right to it. A combination circuit is the dual use of series and parallel connections in a circuit. And so here in this picture, we've got a battery here, and this portion of the circuit would be parallel. Okay, basically the current has two options. It can go through light bulb A or it can go through light bulb B. But these two guys right here, light bulbs C and D, they are in series. Okay, and so that is basically a combination circuit where you have part of it in parallel, part of it in series. Just again to kind of recap the series and parallel circuit, now looking at a series circuit, the current is the same everywhere in a series circuit. Okay, and that current is equal to that in the battery. Also, the sum of the voltage drops across the individual resistance is equal to the voltage rating of the battery. Okay, so those are two things that are kind of helpful to keep in mind for series circuits. The other thing is there's this formula that we talked about where the overall resistance of the collection of resistors can be basically used for this equation. So if you want to take all the resistors in a series circuit and make it look like the equivalent of just one resistor, you can add them up, resistor 1 plus resistor 2 plus resistor 3, or however many resistors there are, add them all up, and it gives you the total resistance. And it's kind of like saying instead of having 3 resistors, you just plug 1 in at X amount of ohms. Okay, so that's a recap on the series circuits. For parallel circuits, the voltage drop is the same across each parallel branch. So if you have a 12-volt drop right before you enter into that branching point, each of the branches is going to experience that 12 voltage drop. The current is not the same in each branch, but the sum of the current in each individual branch is equal to the current outside of the branches. And then we also discussed this formula for basically figuring out the total resistance, where you can take 1 over the equivalent resistance is equal to 1 over resistor 1 plus 1 over resistor 2 plus 1 over resistor 3. So I'm just flying through this real quickly, just again to refresh your memories on what a series and parallel circuit has. Now, I'm going to give you some strategies for solving combination circuits, because really, you know everything you need to know to be able to solve combination circuits, but these are just some general strategies. First is transform the parallel circuit portion into a series circuit by using this formula. So basically get rid of those resistors and make it just one resistor that is in series with the other resistors. Okay. Once the circuit has been transformed from a parallel and series circuit to just a series circuit, you can then use this formula to make all the resistors just one resistor. Okay. Once you figure out the total resistance of the circuit, then you can continue your analysis by using Ohm's law, which is V equals I times R, to determine the voltage and resistance values at various locations in this circuit. And we're going to do one example problem later on in the video to kind of give you a look at how you might use some of these strategies when solving a combination circuit. Some other suggestions would be, one, to draw a diagram. If you do not have a diagram, I cannot stress enough the importance of drawing a diagram. Being able to see it on paper is so much more powerful than trying to do it in your head, so please draw yourself a diagram. Also, organizing yourself, writing down what you know. What are the known values in the problem? So do you know the total current? Do you know the value of resistor 3? Do you know the voltage at various points? Anything you know should be written down so again you can see it on paper, because just trying to sort through it all in your head makes it way more challenging. The third thing is to know the appropriate formula. okay, for the equivalent resistance of series circuits and the equivalent resistance of parallel circuits. If you're using the wrong formula, by golly, you can draw the best picture in the world, but you're still going to get the wrong answer. So it's really important that you are using the correct formulas for the correct type of circuit. So being able to identify a series and a parallel circuit is definitely key. Okay, so here we go. A combination circuit. Let's take a gander at this. All right. So right off the bat, the picture is drawn for me, so that's nice. I don't have to do that. But right after the bat, I know that the battery has a voltage. Battery voltage is 60 volts. Okay, and I'm looking at this circuit, and I know that resistor 1 is 5 ohms. And just make that one a little better. Resistor 4 is 6 ohms. Okay, so I'm just kind of writing down stuff I know. Okay, resistors 2 and 3. I think I'm going to do something with these guys, and the reason why I'm thinking I'm going to do something is because these guys are in parallel with one another, and I want to get rid of that. I want to make this be the equivalent of just one resistor. Okay, we can certainly write down what they are right now if you'd like. Resistor 2 is 8 ohms, and resistor 3 is also 8 ohms. Okay? But like I said, I want to crunch this down into being just one resistor. And the way to do that is 1 over R equivalent equals 1 over R1 plus 1 over R2. Okay, and so basically I'll kind of fill in the numbers here. 1 over 8 plus 1 over 8. And if you do this math problem, you would get an equivalent resistance of 4 ohms. Okay, and that's important because now instead of this being two 8 ohms resistors, we can kind of pretend that this is a 4 ohm resistor here. And now instead of having this portion being parallel, this is now actually a series circuit. I have a 5 ohm resistor, a 4 ohm resistor, and then a 6 ohm resistor. Okay, so now I can actually figure out the entire resistance of this whole circuit. And the way I do that is by using the formula for a series circuit where R equivalent, I have a hard time making Q's, R equivalent is equal to R1 plus R2 plus R3. Okay, well, R1, and you know what, maybe what I will do is I'm going to call this guy R2. Okay, I'm going to call this guy R2. And this one I'm going to change to R4 because I wrote these knowns down here. So R1 is 5 ohms plus R2, which we just figured out was 4 ohms, plus R4, which was given to us, R4 was 6 ohms. And if I add this all up, I get an equivalent resistance. Basically, if I take all these resistors, it would be the equivalent of having one 15 ohm resistor. Okay, so now I know that this circuit is basically the equivalent of one 15 ohm resistor. The next thing that I'm thinking I might like to do is figure out the current in this circuit. And remember, the current is going to be solved by finding out Ohm's law. And I'm just going to change pen colors here just because there's going to be a lot of writing on this. And so I think a small change in pen color might be worthwhile. So I'm going to use Ohm's law to find out the current, where V equals I times R. And the voltage is 60 volts. I do not know. And R is 15 ohms. Okay? And if you do the algebra here, you would find out that I total is the equivalent of 4 amps. Okay, 4 amps. And you may say, well, who cares about that? Well, basically what it's saying is that there is 4 amps of current going through this resistor, and there are 4 amps of current going through this resistor. Okay, so there's 4 amps here, and there are 4 amps here. Okay. At this point here, at this parallel branching, I don't actually know the current, because remember the current can be different in each of these resistors. In the branches, the current can change. So I'm going to save this for last. This will be the last thing that I do. Because the next thing I'm going to do is I want to find out what kind of voltage drop, a current, occurs at resistor 1 and at resistor 4. Okay, so I'm going to find out the voltage drop at resistor 1. And to do that, I'm going to use Ohm's law. V equals I times R, where the voltage is going to be the thing that I'm trying to find out. Okay, so I know that the current at this point is 4 amps times the resistance, which is 5 ohms. So 4 times I have a 20 volt drop right here at resistor 1. Okay, so there's 60 volts total going through this circuit. 20 of them are going to be used up at resistor 1. Okay, what about at resistor 4? What about a resistor 4? How much voltage is used there? Well, I'm going to use the same thing, Ohm's law, V equals I times R, where I is 4 amps times the resistance, which is 6 ohms. 4 times 6 is 24 volts. Okay, so there's a 24 volt drop here at R4. Okay? Now this is where you really have to have a strong understanding of circuits. Okay, we know that 60 volts are pumping through this circuit, and basically 20 plus 24 is 44 volts have been used. 44 volts have been used. What's left? Well, 60 minus 44 would be 16 volts. Okay, and so what that's saying is there are going to be 16 volts going through this parallel portion of the circuit. All right? And if you remember, in a parallel circuit, the voltage drop is the same at resistor 2 and at resistor 3. So both of them are going to experience a 16 volt drop. Okay? So I know the resistance, I know the voltage drop. Can I determine the current at resistor 2 and at resistor 3? The answer is absolutely. All right, and so let's do that. Okay, so we'll do resistor 2 first. So again, I'm going to find out the current. So I'm just going to manipulate Ohm's law to say I equals V over R. All right, and the voltage drop is 16 volts divided by the resistance, which is 8 ohms. And so 16 divided by 16 divided by 8 is 2 amps. I'm getting ahead of myself. All right, and so that is the current here, 2 amps. Okay. What about at resistor 3? What about at resistor 3? What is the current there? Well, I'm going to use the same thing, I equals V over R, where the voltage drop is 16 volts, the resistor is 8 ohms, and 16 divided by 8, well, by golly, that's also 2 amps. Okay? This problem turns out to be almost on the hair of easy side because basically these resistors are the same, 8 ohms apiece. In a lot of problems, this will not be the case, and so the current won't be the same in both of those resistors. So just kind of keep that in mind. But this again is to give you a flavor of combination circuits, and again, if you're feeling like, holy cow, this is really tough, it is. It's challenging, but once you get it, I think you'll like it a lot, and we're going to practice a whole bunch in class. That takes care of this video. I will see you guys next time.